Because part of the escaping flux of these magma ocean planets comes directly from the surface, this means that observations of these planets may enable us to distinguish different properties in the dynamics of the underlying magma ocean. The top part here illustrates different parameterizations of the interior that translate into different dynamical properties of the magma ocean. The first case here is our fiducial case, trying to reproduce the previous approaches in the literature that are based on boundary layer theory. In this case, the mixing length in the magma ocean, which is analogous to the eddy diffusivity KZZ in atmospheric sciences, is constant throughout the mantle. The magma ocean is directly bounded by the atmosphere, and there's no separation of solid and melt phases in the magma ocean. The next cases then systematically relax one of those assumptions. Number 2 here, instead of keeping the mixing length constant, it allows the mixing length to vary with depth. In this case, scaling with the distance to the nearest boundary, meaning either the core mantle boundary or the magma ocean atmosphere interface. Number 3 here allows solid melt separation by permeable flow. And number 4 introduces an ultra-thin thermal boundary skin where the heat flow through the skin is actually conductive and therefore diminishes the heat flow to the atmosphere by orders of magnitude. The bottom part then explore the quantitative results or consequences of this for the spectra and for the mantle melt fraction, the mantle temperature, which are the underlying causes for the differences in the spectra. The blue lines here are for an H2 steam atmosphere, H2O atmosphere, and the green curves are for an H2 dominated atmospheres. Now, what you see is that for a different parameterization, in particular variation in the boundary skin and in the mixing length theory, this translates into quite different internal properties of the magma ocean, and for here in this case that we show, in the H2O case, translates to differences in the atmospheric spectra. Thank you very much.